So, the International System of Units. This is an SI unit, it's called. It applies to all different measurements in science. The SI unit for pressure is a Pascal. Am I going to that? Pascal is PA. 1 Pascal equals 1 Newton per meter squared. 1 Newton per meter squared. So the amount of force exerted over a certain distance, right, is pressure. So when we think about it, it's like, for the molecules, it's like the force they're exerting over the distance of a can. Okay? So 1 kilopascal, is 1,000 pascals, not kilopascals. Okay, now, there is two things called SATP and STP. We need to know about these. So, STP stands for Standard Temperature and Pressure. Standard Temperature and Pressure. Now, when we think about atmospheric pressure, this is the force per unit area exerted by air on all objects. At sea level, atmospheric pressure is 101 kilopascals. Standard pressure, which is what we use for STP, is 101.325 kPa. So, on your gases memorization sheet, under STP, beside P, you write 101.325 kilopascals. Okay, on the STP P one, that's what you put. Okay. This is equal to 1 atmosphere, we say, or 1 ATM. So if you have to convert between ATM and kilopascals, that's how you would go. Right? Oh. For many years, standard conditions for work with gases were at a temperature of 0 degrees Celsius. Why is that a problem? If all scientists say, when you work with gases, you should work at 0. That's a little cold. I'd say so. I wouldn't want to work in a lab that is 0 degrees Celsius, right? No, that's difficult.
And when, like, your water and stuff.
Exactly. So it's not a practical lab situation. Okay, so it's not practical for experiments. Or just working at all with gases. Oh, did I not give it to you? Okay. So now, for standard ambient, so SATP stands for Standard Ambient Temperature and Pressure. So T, little t, is 25 degrees, and P is pressure, which is 100 kilopascals. The new standard is much closer to laboratory conditions. So now, take out your memorization sheet. Whoopsies. And for STP, so we'll fill it in. So for STP, you should have your pressure. Now little t means temperature, and you put 0 degrees there. Now the big T that is below it, I'm going to teach you later what that means, but just write it in for now. It's 273.15 Kelvin with a capital K. Your pressure is 1.325. Now the SATP, okay, is your pressure is at 100 kilopascals. Your little t is 25 degrees Celsius, and your big T is 298.15 Kelvin. Now the little t and big T, that's a conversion. Both of them are referencing temperature, but the big T is in a different unit, and that's called Kelvin, and 0 Kelvin is like absolute 0. Yeah, so, but I'll teach you later more about the Kelvin scale, but that's just for that sheet. So, okay. So, although gas molecules have very little mass, the Earth's gravitational pull keeps them near the surface of the planet, which creates our atmosphere. Pressure is force per unit area. So just like with that can, I really need you guys to think about pressure in this way throughout this whole unit. That you think about molecules exerting a force over a certain amount of area. So with our can, those gas molecules bouncing off the wall of the can was exerting a certain amount of force. When we cooled the molecules, they couldn't move as much, and so they exerted less force. So the pressure decreased. Okay? It's just really important that you have that whole idea of how molecules work when you're thinking about gases. Pressure is exerted in all directions to the same extent. So in every spot of the can, the same force felt is the same, or the force felt is the same. In all directions to the same. Okay. Now, atmospheric pressure is the force that a column of air exerts on a particular area on the Earth's surface. This is we kind of already talked about. Air is less compressed as altitude increases. Therefore, less pressure is exerted. So if you're climbing a mountain that's like substantially high, you will experience that there's a lot less density of that air available to you. And so, oh man, I could talk about an hour about this. It's so cool. There's like Nepali people, especially ones that live in very particular tribes, have developed their red blood cells are different, and they have more EPO, which is erythropoietin, which can makes more red blood cells to carry the oxygen. Anyways, okay, so they can go to higher elevations but still have the same amount of strength because they have still more oxygen going to their muscles. These particular people, they're kind of the way they name their tribe, their last name is Sherpa. Okay, if you are genuinely a Sherpa, you come from a specific, it's almost like that's your last name. It's not just your occupation. So these people, but it's now people use the term Sherpa just to almost describe an occupation. So if you want to climb Everest, most people can actually do it. Okay? Most people can physically climb Everest because it's actually not very strenuous of a climb.